And my name is Gavin Horn. I'm the director of the research program here at IFSI, also a fire investigator with the Savoy Fire Department. If any of you live in Savoy, as well as the Mavis 28, there is an area or a regional group that goes around and investigates fires throughout Champaign County and the surrounding areas. So if there is any sort of issues, we go out and we make this stuff operational. So again, hopefully going to have some information that's new for you. I think a lot of this stuff is hopefully going to reinforce what you already know from the classes. So again, don't hesitate to stop me and ask any questions. We're looking here at origin and cause awareness. Okay? We're just looking at it from an awareness level because this will not train you to be an investigator. Okay? There's an extensive training program that Chief High runs here at IFSI. Not only do you have to be a certified firefighter level to basic operations firefighter in the state of Illinois, then you have to go through 3 40-hour modules to become a trained fire investigator. And then if you go work for the police side and become an arson investigator, there's another series of training that you have to go through. So in the 45 minutes we're going to cover here, there's no way we can get through even scratching the surface of the 120 hours that's necessary to become a fire investigator. But we're hoping that this is going to help you understand some of the issues that we face and how it relates back to the class that you have in forensics. Fire like this is easy. Right? If this fire goes out at this point, you can see right here, this individual has decided there's a little trailer, so igniting the fire over here and have it going to a couple different places. If this fire puts itself out, which fires actually tend to do, depending on how it's set up, or if it gets suppressed very quickly, this is a pretty easy investigation, right? That leaves a burn pattern behind that's very easy for us to look at and find out where the fire started, and then we can start to think about what caused that fire. We want to find the origin, the first place where it begins, and then what are the things that came together, and we'll talk to you about that. We need to make sure the fire triangle or fire tetrahedron comes together at some location, and that's what we're looking for. That's where the science comes in on this. Unfortunately for us, very rarely do we get something like this. Very rarely, this is a smoking gun for us. Quite often, it looks like this. Now, this is a scenario where there is a significant level of damage, where it's gone to the point of, in some cases, structural collapse. Very challenging investigations in this case. So this is the range that we might see, from a huge amount of damage, in this case where you can see actually it must have been cold because there's some icicles hanging off of there when during fire suppression. Water comes in there, washes away some of the patterns that we're looking for. Sometimes the force of the water or even the damage to the fire causes a collapse of the structure. And then digging through this becomes a very time-consuming and a very difficult operation. But this is where the trained fire investigators come in, where you could get to after, again, 120 hours worth of fire investigation training. So before we go into that, looking at some patterns that we might see, we want to figure out why this is important. Right? So why do we care enough to investigate these fires? There's a lot of other things that are going on. Why do we waste our time? We just put it out, we can pack up and go back. Right? That's what the fire service could do. But there's a lot of other motivations for, I'm sorry, I keep walking out of the camera. So, all right, good. I feel like having a leash if I'm stuck over here. There's a lot of reasons that we need to investigate these fires, and just go through a few of those. First of all, these are some stats that are pretty representative of the fire problem that we have in the United States over the past 7 or 8 years. It stayed pretty consistently across the board. Somewhere between 1.2 and 1.5 million fires in the United States each year. It's a very large number of fires for an industrialized nation that has all of the safety and awareness that we have here. Some people don't realize that because most of these fires don't make it on the front page, don't make it to the newspaper. 1.5 million fires each year. Between 2,500 and 3,000 individuals, citizens, lose their lives as a result of fires, and another 100 or so firefighters die each year in the line of duty. Almost 20,000 injuries to civilians, and look at the amount of direct property loss. Almost $12 billion each year are lost due to fires. Now, if you think about one of the big things that make newspapers, earthquakes, tornadoes, hurricanes, all the natural disasters. If you put those natural disasters together, each year, annually does not typically reach what we see from fire losses. So huge numbers. The reason we have to address these is to reduce the number of people who die and reduce the loss of property in the fire service. We're busy in the fire service. Every 23 seconds, there is some fire department in this country that is responding to a fire. Structure fires, that's not just fires in cars or exterior fires. Structure fires, about 1 every minute. Okay? And a civilian dies about every 3 hours in the United States. All reasons why not only is the fire service in place to help to reduce some of these and reduce the spread of fire, why we need to investigate them to reduce these occurring. So why do we investigate fires? It's pretty straightforward. We need to find the point of origin of the fires. We need to find where everything went wrong to cause this to occur. Everyone know what the fire triangle is? Heard what that is? What do we have for a fire triangle? Oxygen, fuel. We need one more. Ignition, which is a more general way of saying it. Heat. Heat. You need some sort of heat, some energy to create that fire, to kick off that chemical reaction between the oxygen and whatever that fuel is. Okay? What we need to do is find what is that point where those things all came together. And again, from the first picture I showed you, that's pretty easy. It's much more difficult when you have a whole lot of damage. Once you find that point of origin, then you can figure out what caused that. What are those things that came together at that point? Is there something that's typically plugged into an outlet right there? Was there a lightning strike in this area? Was there nothing around there other than possibly we have some leftover matches or a lighter or something else that shows us what actually caused that fire to occur? We understand the circumstances of that fire. Now that we know what caused it, were they all brought together intentionally or was it unintentional? Was it an accidental fire or was there some intent in terms of starting that fire? Because that has a significant impact in terms of the legal implications. There's also scenarios where these could be due to something that we purchased. There's a lot of recalls that you might hear from various different things. I think hoverboards are probably the one we heard the most commonly. Actually now, Galaxy Note has passed that. Anyone of you have a Galaxy Note? You might want to take that one back.
It's a 5.
Okay, it's a 5. You're good. Right? So what happened? They found that there was a series of those that actually failed and determined that there was a problem with that. So again, we'll get into that in a little bit, but that's number 4 here, to identify faulty products. If there's just 1 or 2 that are burning of the millions or so that are sold, they understand sometimes things go wrong. But if there's hundreds or thousands or tens of thousands of these same products that start causing fires, like the Galaxy Note, like some of these hoverboards, we realize we have a problem. There could be some reason to recall and let that manufacturer know that they got a big problem before it causes more issues and possibly ignites some fatal fires. Education October is Fire Prevention Month. Every year we get a lot of information out, and a lot of that has to do with our understanding that comes from these fires. You've probably heard stop, drop, and roll, all sorts of stay low and crawl out of the structure. I'd highly recommend for those of you who are interested in understanding risks of fire, there's a new public education message that's out that Underwriter Labs just released this year. It has to do with closing the doors in your house. When you get out of the house, if there's something on fire, shut the doors. When you sleep at night, close the doors. Because it's amazing the effectiveness of a hollow core door at keeping fire from one room to the other. A hollow core door can mean the difference between life and death for you or your family members. And that was only determined after looking at a series of fires, a series of research studies, and finding, you know what, that $40 door made that room completely inhabitable while this room was completely engulfed in flames. Of course, it's limited, but the point is, if we understand what's happening, then we can get the messages out and can help the public to either stop causing the fires or to protect themselves from that fire. Codes change consistently. It's another aspect of Chief High's job is to help train individuals who do inspectors or understand more of the codes. The reason that buildings are built a certain way, in some ways, has to do with fires in the past. For instance, notice all the doors that swing out of rooms like this have to open out. That was a result of, among other fires, the Iroquois Theater fire up in Chicago, where over 400 people died as a result of being stuck in a theater that caught on fire and the doors opened inwards. So you can see the crush of people, you all trying to get the heck out of here if there's a fire, and 20 people, 50 people, 100 people are stuck at that door. It's not going to swing in. That's why those doors swing out. That's code now as a result of some of these fatal incidents. The insurance industry is obviously very interested in understanding why fires start, so they know who to pay or who to sue, or in some cases both. So they're very actively involved in this, as well as supporting some of the product recalls. There are bad people out there. There are people who intentionally set fires, some for profit, some for revenge, some for other reasons. It's important to catch individuals like this because, as we saw, the number of fires that we have, the number of fatalities is critical, and we need to reduce that. Fortunately, those numbers have been declining, at least since the 1970s, where there was a lot less stringent legal implications for creating arson. And finally, it's the law. We have to do it. It's our job, and the fire department, our chief has to determine the cause and origin of the fires. That's part of the job of the fire department before they leave. So all these things are necessary for why we fight these fires. So the question then is, how do we go about this investigation? And again, very briefly going to be able to go through this, but this scientific method is something that I assume you've all seen at one point or another in one of your classes, right? This is a science class. So we use the exact same method as you've gone over in the class. First of all, you have to recognize need. It's pretty obvious usually. Something's on fire, we got to figure out why. Okay, that's pretty straightforward for us. But then we have to go through the process of figuring out what that problem is, defining the extent and the scope of that problem, collecting the data from inside that area and that scope, analyzing the data, and from that data we develop a hypothesis, right? We develop a guess, scientific guess. And then we have to test that hypothesis. And this is not just straight down here. We don't just collect data once, analyze it once, develop and test hypothesis. Sometimes we figure out after testing the hypothesis, looking at all the data, we've got to go back and collect a little bit more data. So all these things should really go back to defining the problem, collecting the data until we come to the point where we can select a final hypothesis. If everything goes well, we can eliminate all the possible causes of the fire. We can narrow it down to one specific area. It doesn't always go that way, and sometimes we have to leave the fire undetermined. So first of all, as I mentioned, recognizing the need, it's pretty straightforward. We've had a fire, it has to be investigated for all the reasons just showed you earlier. We need to define the problem as what we need to conduct in this origin and cause investigation. Where that's going to be limited by, how far out are we going to collect evidence from, what is the scope of that investigation in the definition. And then we get into that iterative process. We have to gather all the facts that we can about the incident, and those come from all sorts of different places. Evidence and data are everywhere on the fire ground. It's not just trying to understand the fire scene, it's talking to the occupants of the structure, talking to witnesses, collecting. In this case, many of you have cell phones, and if there's a fire out there, I guarantee there's probably 20 to 30 different views of that fire if it's in some populated area. So collecting that information. That can be critical. It's much easier to find from pictures early in the fire than going back and looking at the burn data at the end. We need to look at weather patterns. We need to talk to the firefighters, see how they went and came and went, possibly talking to neighbors. There's a lot of different pieces of evidence that we need to collect, and then got to sift through all of that. Look at what all that data means. Categorize it. Put it in different means that can help us to nail down a specific hypothesis or theory. And again, we're typically not trying to develop one hypothesis. This is where we look at all sorts of different possible ways that this fire can start. Right, what are those different ways that are just even remotely possible, and see if the data supports that. So that's the testing part. Does this theory stand the test of the data? Does it support it? Does it not support it? If we go to court, can we defend that position based on the data that we have available to us? If not, do we have to go back and get more data? Or do we have to get rid of that hypothesis? Now, going back and getting more data can be challenging right here, especially because a lot of times people want to clean up the house. Or if it's badly damaged, knock the house down so kids don't get in there and cause other damage or get hurt. So it's not always possible to come back and collect more data after the fact for some of these fires. Once we've tested it and we select a hypothesis, then we can give a definitive reason for the cause and the origin of the fire. Any questions on that before we move on to a little bit more detail? Nothing?
Well, if you have
Sure.
a fire,
Yes.
like a suspicious fire, and you go out and you investigate it,
Yes.
you have to go back and collect more data. Is there a certain amount of time you can leave tape around that house so no one can go past the tape?
Yes, and we won't have time to go into all the legalities of those details, but when we are on scene, when the fire department is called to that fire, then there's a thing called the plain view doctrine, where you can collect evidence as needed. Coming back, you will often need to have a warrant in order to collect that evidence, unless someone has stayed on scene there. Chief, I could actually explain that probably in a little bit more detail than I can. But we can put the tape up there to keep people away and to warn them of the dangers of that fire, but we have limited legal abilities as soon as the fire department leaves the scene. But again, going back and getting the warrants to collect additional evidence can be done. If it's proven, again, you have to go to a court of law and get that approved. But there's limitations, again, as people start to come and go, the value of the evidence starts to decline when there's possibility for someone coming in and tampering or changing that. Do you know of any limitations in terms of the time to go back and get a warrant for going back and collecting additional evidence?
Generally speaking, the investigators are given the opportunity in a reasonable time frame. This comes back from the court cases of Michigan versus Tyler and Clifford. And basically what had happened here, the fire department went out to do the investigation and it was dark. So again, you're limited by the time frame. So they were actually allowed to leave the scene, and then when daylight come and they could actually come back and work, they had the time frame to go in there. Now, if we wait an unreasonable time, like 2 or 3 days, that does not work because we could have done the investigation sooner. So this is the thing that happens. Sometimes we leave the scene and we find out there's additional information we need, and that's when we have to go to, there's a couple of ways we can do it. We can ask for consent from the property owner, and if they give us consent to go in there and do it, we're okay. But again, chances are, if they're trying to hide something, they don't want us to know, then they will not allow us to go, and then we have to go get what we call an administrative warrant from the judge. The administrative warrant gives us the reasons to go in and proceed with the investigation. If during that time we find criminal activity, we stop where we're at there, and then we go back and get a criminal search warrant, which allows us to proceed on a crime scene. So those are some of the steps we have to do as we do the investigation. Okay? Cool.
Yeah, great question. Anything else? And we'll touch on just a little bit of that towards the end here of this session. So, what do we do for a fire investigation? There's a very controlled process that we typically take, and we'll go through all of that in a very high level and what kind of evidence we collect and determining cause and origin and motive. But overall, what's important is skills to observe. And we'll show you a couple pictures, and you'll probably be able to look at those pictures and get an idea what the patterns you're seeing there. Once we identify certain patterns through our observation, then we have to go back and understand the science behind the fire. How does the physics and chemistry that we know that governs a fire line up with the evidence that we have left? But if we don't observe it and we cannot collect that data on scene, then we don't have that to analyze when we come back. So taking pictures, good drawings, good sketches and layouts of the structure are critical in order for us to be able to go back and compare anything to that. We need to be able to look for any indicators, something that might not be ordinarily there. Might be indicators of either an incendiary fire or something that's not what we would typically understand, right? Especially from a public investigator's perspective, we're limited in the fire department where I'm at to as soon as we have an indication it might be incendiary or it might be an intentionally set fire, that we bring in the state fire marshal. It elevates to a higher level within the level of investigation that we do at Savoy. But we need to identify that very early and to bring in those additional resources. We also want to leave the scene as undisturbed as possible, because not only for additional investigators, but if there is, say for instance, a faulty piece of some appliance that has caused the fire, there are going to be individuals who will be inspecting it and from the size of the appliance manufacturers who are very interested in it. And if we destroy all the evidence or destroy the scene, they won't be able to come back and do their investigation as well. So if we are moving things, we have to document where they came from and be very careful to leave the scene as undisturbed as possible. We also typically work from the least damage to the most damaged side to not get too focused in on what is sometimes what appears to be the most obvious location of the fire itself. So again, we're talking about this origin. Ideally, we can find the point of origin. Sometimes with the amount of damage available, we can't. We have to just look at started in this area of the structure. The point would be exactly where that fuel, that oxygen, and that heat source came together. Quite often, because, say, an entire chair or couch has been burnt, we can't tell it's at that point, but it's in some location within the structure, and we determine that the area of origin. While we're doing this, we need to be very careful of all the hazards that are common on the fire ground. And it's just a picture of various different things that we need to keep an eye on. First of all, there's a lot of electrical and other types of trip and fall hazards that can come from all of the different utilities that are commonly run in the ceilings of most of our homes, particularly in resident or commercial structures as well. We have to control the utilities. We have to control access to the area so there's no vehicle traffic that can get in the area. Quite often, particularly at night, this can be challenging because of our ability just to see anything inside there. When we shut off all the lights that are inside the structure, we have to bring our own lights inside there. This can also be very challenging as we get to the winter months. When firefighters apply a whole lot of water, there can be a significant amount of water inside a structure. If there's no heat in there, then that can become a solid block of ice. Another thing that can delay an investigation, because we have to chip through a couple inches worth of ice in some case to get down to these. But all of these things are different hazards that we have to address. Particularly once we get into some of the structural elements, these are ceiling, the ceiling has actually come in, and those are the floor joists for the second floor, and if those become compromised, then we have to worry about structural collapse. If any structural element becomes compromised as a result of the fire, we may have to go in and reinforce part of the structure before it's safe to go in and do some of these investigations. Once we've done all that and it's safe for us to enter, we're looking for, again, that point where the fire triangle comes together. And already made this point a few times, but what they leave behind here, what we're really interested in, these burn patterns that are produced by all sorts of different things. The burn patterns aren't only produced by the fire itself, but these hot gases that move throughout the structure can leave behind a pattern, leave behind various different clues as to maybe where they came from as well as where they were going. The problem with all of these, and actually a research project is currently ongoing up at Underwriter Labs right now, is that these patterns change. As a window fails, what we had one pattern before, a window fails, now it's got fresh air coming from a different location, and that can now change the patterns. And it's very difficult without having all the other evidence to be able to locate, to match up these burn patterns with what exactly happened throughout that fire. So again, when identifying these burn patterns, we go from the area of least damaged to the largest damage. Typically, particularly for an interior fire, that is looking through the outside of the structure in a very controlled manner, working to the inside of the structure, and then finally getting ourselves down to the area that have the most damage on the inside. Reason for that is sometimes an investigator can get too focused in on something that looks like a very obvious form or an obvious source of that fire and then miss everything else around that could indicate other possible causes of the fire. So this is a typical exterior examination. Look at all four sides and four corners of a structure. Certain things we're looking for here are utilities. Are utilities attached or not attached? Are they in service? Is there electrical service? Has the building been abandoned? What is the condition of the structure? Anything that can tell us how well the structure had been kept up before and after. This can also tell us, if you look at this roof here, we've got some concerns about potential structural stability to go inside that area or not. It tells us a little bit about possibly how well the structure's been kept up. The area on the outside might tell us a lot of information about how much stuff is inside there, the upkeep of the structure, as well as any anything on the outside that can add additional weight to what occurs before we even look at any of the burn patterns. From this side here, you don't see any significant results of the fire. We go around to the front, now it tells us a completely different story. Right? Now we need to look at these patterns, how they exist on the outside. Do we have a fire? Where do we see the largest amount of damage? Even though we have the largest amount of damage on the upper floor here, we also have a significant amount of damage here on the first floor. So we need to document all of these different burn patterns and start to consider why we have some of these patterns on the outside. After that, moving to the interior, And again, before we get to the interior, we got to limit the access to that. The firefighters have obviously already been in there. We want to try to reduce the opportunity for anyone that's not involved in the investigation to go back inside, so that there's no additional damage that occurs from firefighting operations, but also so homeowners don't go in. A lot of them will want to come in and get some valuables out, but we have to be able to restrict that access, so either intentionally or unintentionally there's not some changes to the patterns that we see or to the evidence that we might be able to collect. Again, have to appropriately document where all the evidence came from, preserve that evidence, and then prevent any additional work until we have all the data that we want. So when we talk about overhaul here, this is firefighters going in and looking for other causes. If the firefighters take down all of the walls to make sure that there's no fire behind that wall, then we don't have the patterns that are left on that wall. The firefighter can come in here and start to cut through all these things and make sure there's no damage behind there, but then we might not see some of this smoke that's coming up from that first floor. They rip off all this siding that's now in the yard, and we can't do anything about putting that back on there. So it's very important for us to look at it before the firefighters destroy everything. Yeah?
So you guys would start an investigation after they've got the main fire out and they're still looking for reflash areas?
Yes. Yeah, we'll wait. The main body of fire is out, and we'll often ask for them to hold off on the overhaul process. There might be still having to go look for some areas. If there is active working fire, the investigation can't start before that, at least on the interior side of the fire. We need them to put the fires out. But oftentimes, once we get the fire out, there's a little bit of smoke that's still coming from here and there, or we can possibly hear some crackling, maybe some embers that are still going. Ask them to kind of hold off on that before we document, take pictures of that before they pull that down. It's not always possible, depending on the damage and the extent of the fire. But we will typically ask for them to hold off if they can do it safely and we can get in there safely. So it's critical to be able to work with the fire departments as well on these. Okay, so interior fire. If you take a look at this, your eyes probably draw to one area, right? Any ideas about where you see something that might have a significant amount of damage?
Is it a fireplace?
Well, see, now it's important. First thing, what's very hard about these is you need to have the context for these. This is the hard part of looking at pictures and trying to go back and do a cause of origin inspection. This is actually a hood for a stove. Okay, so there is a commercial stove down here, and this is a hood that collects all the smoke and all the grease and everything that comes up from there. Okay, and so this is a ceiling. Okay, you can see this is a ceiling fan. It's a high vaulted ceiling. This is another one of those cases where it's relatively easy to see, because these beams here kind of keep that smoke into one area, right? So you can see here, here to here, there's much more smoke staining that's in that area, and that can kind of point you right back down to something that might have occurred right up here. You also can see the patterns right here. There's obviously some heat damage in the edge of that hood, and a significant amount of burning right in this location right here. Right, so in this case, all these patterns kind of point right back down. A lot of it is possible because you have something that kind of keeps all the smoke in one area instead of allowing it to spread out into the entire structure. And this was suppressed relatively early in the scenario. So if you look at this, I think most of you can agree that it comes kind of right down to the damage that we see right in there. All right. So this is one, particularly if you're seeing it in 3D and in living color, it's much easier to very quickly go in there and take a look at that scene, and we can start documenting. But again, the risk is that we look too closely in here and don't look down at the fire or down at the burners, or possibility of grease igniting farther up into this structure. There's a lot of other possible hypotheses that we need to test all of them. Just because we visually see this damage right here, we've got to consider all of the other possible ways that this could have started. Because while that could be a burner that has gone out of control, it could also be buildup of grease. It could also be someone who's intentionally set a fire in that location and found out a way of making it look like it's something else. That's why we need to look into these. Visually, you can see a whole lot. It's a lot of great evidence. We've got to continue to look at other areas. Some other burn patterns that we see. This is a very common one. In the old days when I was trained, this is how we would locate what we would, at least at the time, we're quite confident that this is going to be the origin. See, this is a wall. This is wood paneling that's on a wall, and you see behind here are 2x4s against a brick wall. So this is wood paneling that would be the typical interior of a structure. And when a fire starts low, we know that the hot gases go up, the balloon expands, right? So those hot gases expand out. And we have this V pattern that usually comes right down to something that's burning, right? So, and you can see here, there's actually some protected areas on this wood paneling right here. We've got a bit of low burning right down here, and it goes off in this V pattern. So that points back down to what many might immediately say that is the origin of the fire, but that could also be the case where we just have a whole lot of fuel that's down there burning. The fire could start somewhere else, and this just happens to be the place where we have a lot of fuel, like a chair, like a sofa cushion, like a pet bed or something that would be down there that has a lot of fuel that's down low. That's why we got to take these pictures and put them back with everything else that's within them. But every time we see a V pattern like this, we know that we've had something burning that started down at that location. There might be multiple of these throughout a room depending on what sort of fuel package you have. Or if it was intentionally set fire at multiple different locations, we might have that. So that's where this becomes a part of the evidence, not all of the evidence that we have. Also see we've got some sort of electrical power, some utilities inside there. So is this an electrical fire where we had something plugged in down there and it was caused by some electrical malfunction or something coming in contact with a space heater, for instance, that was overheated. Very interested in what happens on the floor, particularly patterns that are protected. Having an area that does not have the same amount of fire damage as others could tell us where furniture was laid out in the structure ahead of time. Could also tell us about things that had been moved at one point or another. So in addition to the damage on the walls, we're very interested in what is the damage pattern on the floors, and particularly interested in what are these protected spaces. A lot of times we'll find evidence several layers deep. And one other area, thing that we look for quite commonly on the floors, if there's any concern about there being an accelerant used, it's often put on the floor, or trailers. You saw the picture in the beginning where there was wax paper was used to start a fire here and move it over to a fuel package in the other area. So any evidence could be left behind from any indications of intentional fires that might have been used or might have used accelerants of some sort. A couple other pictures of some of the patterns. Again, just talked about this already. Here's another scenario. This is a front door. And if you look at that again, we look for a V pattern that comes down. You see here right along this side, we see it coming back down, a little bit of damage on the floor right in this location. Your eyes can, if you relax your eyes, you just allow it to draw you back to one single location, then you start to think about why would that occur? What would be right here just inside a front door that might cause that fire? What's that? Doorbell? Possibly, but doorbells are typically very low power. We've got a outlet right there. Was there some electrical equipment that was there? Possibly. Would you typically have that sitting right in front of your front door? No. Coat rack? Possibly. So again, now we have these patterns that we now have to go back and talk to. Well, what did they have in there ahead of time? Can we talk to the occupant and figure out what was typically there? Can we talk to them about anything that might have changed? Maybe this isn't the front door, maybe this is a back door that no one ever goes out anymore, right? And so they have a whole bunch of stuff piled in front of there. What would have brought a heat source together with whatever that fuel package is right there, particularly here right next to a door? But there's obviously a pattern you see is this damage, and this is an actual fireground burn pattern, so this is not something that was done for for training. You can see how that damage kind of moves out away from there, just through the burning on the paper of this drywall that's right there. Fire in a basement. You can see this is, unfortunately it's kind of hard in 2Ds with this picture, but this is a stairwell going up here. But you can see how the fire starts low and moves up. You can actually see how it's taken off this picture here, unburnt on the paper down at the bottom there. So you can see the direction of the flow and the movement of the gases. That tells you some information about whether it came from the bottom up or came from the top down inside these structures. Again, something to document. The damage on the ceiling here, you can see a lot of the drywall and is down and damaged as a result of a lot of heat on the ceiling, yet this cardboard box right there is undamaged. This structure obviously has not gone through flashover, which is a process where everything in the room catches on fire, and it's left behind some nice patterns for us to try to trace things back. Another image where, again, look at the damage. This is a corner of a structure. So you think about this piece right here is this corner of that room. Wood paneling on this wall, you see how the damage up top has come down. It's actually curling over. Yet on this side, just around the corner, you've got papers that are attached to that wall. All right, so you can look at damage on one side versus the other to get a better idea of where things might be coming from. And again, as you move farther back here, there's even more significant damage to the back of the structure. So these corners provide a lot of very important information because smoke and heat does not travel directly and do a 90-degree turn around there. There's a little bit of gap as it goes around corners, whether it's an exterior corner like this or an interior corner like here, where we can see some damage. It tells us the direction of the smoke movement. So the fire came from this point to that point based on these smoke patterns, as you can see right here. That directional area, the directional orientation is critical, again, for documenting and identifying where everything came from. We're also very interested in sealing. In this case, the fire burnt hot enough in one place that you might think there'd be a lot of soot on the ceiling, but directly above a fire, it can actually be hot enough it'll burn off all that carbon and all the soot on the ceiling. So we can actually have something that looks clean right above the fire because of the intensity of that fire. Of course, we can also have a clean area like this where the firefighters are coming in and bouncing a stream off of the ceiling. So again, another reason why getting the entire collection, the entire body of evidence is critical to understand what the firefighters had done as well as what this means for the fire patterns that are left behind. Once we get all of that information, the next step is translating that. This is the science part. Okay? We got all the evidence that we can from the structure. We need to be able to translate that into a reason for why this occurred. And we won't, again, fire behavior lecture can take up to 12 hours in and of itself, but we want to be able to do is translate those images, that evidence, into a scientific explanation for what occurred. So the first thing we have to do is understand what a fire is. Fire is just a combustion process, and there's this very fancy definition that all fire investigators are required to learn from NFPA 921. It said fire is a rapid oxidation rapid oxidation reaction with the evolution of heat and light. Okay, so what that means is just a chemical chain reaction. It gives off a lot of heat and that light that we see in the flames, but the heat is what we're most interested in. Oxidation reaction, again, that's part of having a fire triangle. We need oxygen and some fuel. So all we're doing is very rapidly oxidizing whatever that fuel is. Whether it's gasoline, whether it's plastic, whether it's wood, it's an oxidation reaction. And we know that the only way that this can occur is for atoms in the fuel. So the molecules of whatever that fuel is have to combine with oxygen. It can't do it as a solid. It can't do it as a liquid. It has to be in gaseous form. Okay, so that means there has to be enough energy added to that piece of plastic to change that state to a gas, to mix with the gaseous oxygen and create this reaction. So that's where the heat comes in. The heat is the energy that starts this whole reaction. Now in some cases, gasoline, for instance, will off-gas at room temperature. So we don't need to add additional heat. It just has to be there at a high, I would say for a day like today, it would be warm enough it would start to off-gas on its own. On the other hand, diesel fuel does not off-gas at temperatures that we're at right now. So an additional amount of energy has to be added to that. So these are all things that we need to consider when we're looking at these fire patterns. We need to know about heat transfer. There's 3 ways that heat moves from one place to the other, and these are critical, right? It can go through conduction. That's touching something, right? So if you ever grabbed a hot pan on a stove, heat is conducted from that pan into your hand. It's direct contact. There's convection, which is movement of gases throughout the structure. Gases are liquids. So when that smoke, when all that fresh air comes into the fire and gets heated up and then goes high, it's transferring air through convection. And then radiation, again, is just through infrared waves. So the way the sun heats the earth, or the way a toaster oven heats toast. It's not through direct contact through the gases, but it's through the electromagnetic radiation. All 3 of those are critical on the fire ground and are necessary to translate the burn patterns. The most common that we deal with in the fire service, again, a good question you might have at some point or another on a test if you have this, is convection and radiation. Convection and radiation are the two most common types of heat transfer we're concerned about on the fire ground and in terms of our fire investigations. As I mentioned, we are concerned mostly about the gaseous state of matter, but we'll find fuels in all sorts of types on the fire ground, solid, liquid, and gases. Right? Methane will ignite on its own without having to transfer into a gas because it's already there. Some liquids, again, once we add enough energy, and solids as well. So we need to look at what state of matter do we expect everything to be at this location, and then what needed to be added to that in order to make it into a gas to participate in this fire. The ignition heat sources. This is the energy that's being brought to cause this to occur. Right? All sorts of different heat sources that we can potentially come upon in the fire scene. Some of them we expect to be there. Would we expect to have an open flame? Possibly, right? If we were talking about a boiler or a stove, there's very commonly places where we might have an open flame. In the middle of a living room, we expect to have an open flame? Maybe not so much. Right? Hot surfaces, kitchens, makes a whole lot of sense. Space heaters, if they're there. There's a lot of ways that some of these ignition heat sources are used and will be expected to be in a structure. We have electrical energy in almost all of our structures, right? So we expect those things to be there at certain locations. It's when they're in locations that we might not expect that we need to look a little bit more closely. Sparks and arcs, particularly from electrical sources of energy. Why we don't put extension cords underneath a rug, because as you constantly walk back and forth over an extension cord or shut a door, open and close a door on there, it gets really small and can actually start to arc and cause damages there as well. Energy of friction, actually friction is a pretty common way for car fires to occur. Stuck brakes or two things rubbing on each other can actually get those plastic pieces hot enough that they'll ignite and start the entire thing on fire. Chemical, solar. Solar is actually interesting. There have been documented cases where people have had glass, various different types of ornate glass in their houses, and the sunlight has shone in through an exterior window. It's actually hit that glass at the right time, the right orientation, where it has acted like a magnifying glass. It's focused a bunch of energy down onto some location and created a fire in those structures. Without any intent, it just, bad timing with the sun came at the right spot where that piece was used. Rarely do we see solar energy just creating fires themselves, but we also now have a lot of, there's a new concern that's coming up with solar powered photovoltaic systems in a lot of homes that we have to deal with. So once we have identified what are the fuel packages that are in there, what are the different ignition sources that we have, this is where we're documenting them throughout the evidence collection. And we'll just go through this really briefly because I've touched on each of these points a little bit on the way through. Again, it's critical for us to preserve the evidence. If we can view it and then we destroy it, it's of no use because other people need to examine it, need to be able to have their opinions on this. So while we collect some evidence, we have to make sure that it is preserved appropriately so it can be presented in a court of law, so it can be analyzed by other experts for all sorts of other reasons. So we cannot damage it, change it, and importantly, alter it. While we're collecting that data, if we add something to it on purpose or by mistake, then it's not a good representation of the fire scene. A related term is spallation. This is any sort of loss, destruction, or alteration of anything that is collected as evidence for used in legal proceedings. Okay, so we can't damage or destroy anything that is going to be introduced into a court of law. So we need to restrict entry. We need to make sure that we know what stuff is coming and going from that structure as we're doing our investigation so that it gets checked in and checked out. And there's a chain of custody from the time it's collected to the time it is actually used for whatever final purpose that we have for the legal proceedings of this scenario. These are some examples of the types of evidence that we're going to collect. Photographs, diagrams are considered evidence that we grab from the fire scene. We might collect samples from that fire scene, look at a piece of carpet or wood or something where we want to see if is there something that's spilled on it or intentionally poured on it. So in that case, when we send that off to the lab, we don't have the ability to analyze that on scene. The lab reports become a piece of evidence. We might go out beyond just the people we interview at the fire scene, the fire department themselves, and get expert opinions from some people who know a little bit more, say electrical engineers, and get their opinion about what might have happened or what could have happened right there. In some cases, psychologists and other people are brought in as experts. These all become evidence for this scenario. But it's important, again, as you said, that it accurately portray the scene. We cannot grab all the evidence that just supports the theory that we have and not support the other potential theories that could confound it. So it has to be accurately portraying everything on that fire ground. There's two different types of evidence. Direct evidence, what we can actually get physically from the fire ground itself. Observations made by the witnesses and the firefighters are also an important point of evidence, even though it's considered a testimonial. So there's certain physical things that we can gain as well as testimonial evidence that we can get for them. Talked a little bit about the plain view doctrine. I think Chief High explained that in detail. We have the right to, within a certain period of time, collect evidence from that scene. Once we go outside of that, then we have to obtain either consent or a warrant, and that warrant can actually move up to a criminal warrant if necessary. As we're collecting this evidence, everything has to be documented. We know where this sample comes from. We know exactly what that picture is viewing. And we have to make sure that once we collect those samples on their way to the laboratory, we go through the proper chain of custody before the final legal proceedings end, and it cannot be disposed of until there's a set period of time after all those proceedings have ended. All this leads us to the cause and origin. The next part of this investigation is the cause classification. Once we have figured out what it is that actually came together, it can be classified in a couple different ways. Suspicious is not one of the causes that we can use. We cannot say that this is a suspicious fire. It's not a accepted classification. We can classify them as accidental, which means it was not done by design. We not intentionally do that. There was no person who brought all these things together by design. Incendiary, on the other hand, is man-made, or it was by design. A human intentionally brought all these things together. Whether it was intentional to cause the damage or not is not critical here, and it's being considered an incendiary fire. But there was some man-made design in order to bring all of these things together. We also classify as a natural fire. So lightning strikes are one of the most common reasons why we might classify something as a natural fire. It's also possible through an earthquake that other things can be brought into play that result in a fire. A wind blowing curtains into a candle. That's kind of a borderline one. Wind can cause those two things to come together, so that would be an accidental or a natural fire. Is something that would have to be sorted out in terms of how that would be classified. If it's not possible to isolate one specific cause of the fire, it has to be left as undetermined. And unfortunately, there's a fair number of these in this case, because as you go through the scientific process, you can't just come up with one hypothesis that it can be proven. There might be multiple hypotheses. And if that's the case, it has to be left as undetermined. We cannot support just one theory of how this fire came together. The last little bit we want to talk about here is motive versus intent. And this is particularly important in incendiary fires. So there is a motive, which is defined as the inner drive, impulse, or reason that an action has been taken, which is different from the intent, which is a purposefulness of that action. Okay, so does someone have an overwhelming reason to do something? Is a motive. Did they intend for this to occur? Just because someone may be in debt and can't afford a house or afford a home, that might be considered as a motive. But if they did not intentionally create that fire, there's a difference in terms of how those might be classified. Okay, so motive versus intent is critical, and intent is one of the things that normally have to be proven indicate that there was a crime that had occurred in there. Okay, multiple different reasons why someone, why there might be a motive for creating a fire, whether it's vandalism, they were excited about something that had occurred, positive or negative excitement, revenge, trying to conceal some other crime that had occurred, such as a robbery or a murder, which has been used, fire has been used to conceal each of those. Profit has been, there's some people who do in terms of collecting insurance money, or also have arson for profit. Extremism is another case. But arson is defined under very specific statute. So 1720 Illinois Compiled Statutes, arson is a Class 2 felony. And someone is committing an arson under some very specific actions. Okay, if they knowingly damage any real property, look at the value here. Anything, if they knowingly damage any property with a value of $150 or more without that individual's consent. So that is if you set someone's cell phone on fire, that could be considered an arson. Also, if there's an intent to defraud insurers. So again, don't have enough money to pay for the truck, set the truck on fire, that is considered arson because most likely the truck is worth more than $150. So there's very specific legal definitions of what arson is. And you can see in here, there's an intent in these definitions right here. It's an intent to defraud the insurer. So, went through that very rapidly, and I apologize, got a little stuffed up here, so I haven't been thinking perfectly well here. But that's kind of the overview of what we do in fire investigation. Just want to leave you to, again, looking at the stats that we have about whether or not this is important to do, and whether this might be important for you to look at later on in your careers when you move down some of the investigations or the other areas that are of interest to you all, is that we're trying to reduce these numbers as a result of these fire investigations. Unfortunately, over the past few years, we've seen a reduction in the fires, seen a reduction in the fatalities. A lot of that has to do with the increased investigations that have been done, which have changed the fire codes, which have actually changed the way that we prosecute, way that the lawyers prosecute those who might have conducted an arson. As a result, we're having a reduction in the numbers that we are seeing right here, and hopefully we can continue to drive those numbers down. Any questions about any of that before you go out and take your tour? There was a lot of material. Yes?
So I want us to make sure if I understand something. What is the difference between you and the firefighter when we get some emergency situation, somebody is sick, I call 911. So I saw firefighter come to pick up somebody. So I don't know, what is the difference between you, your mission, and the firefighter when they come to pick up somebody?
Great. So the question is, what's the difference between a firefighter who's there to do an emergency response as opposed to the fire investigator who is coming in to understand the fires for all the reasons we just said? And then first of all, what I'd say is, in some cases it's the same people, particularly in the small areas where we live in. It is the same people, so it's actually can be tricky in terms of how that area is defined. But as a firefighter, we're there in emergency response capacity. So someone has called, you've called, there's medical emergency, you've been in a traffic accident, your house is on fire, you need someone to come take care of that. And we're there in an emergency response capacity. Once that emergency has been taken care of, then in some cases, like in my case, for instance, I could respond on the engine, and then once we've gotten out of the fire attack mode and move into the investigation mode, then we transition over into that next role where you have this attempt to understand what happened and why it happened. So when we're there to respond and put the fire out, we're not, we want to try to keep track of all this information to tell the investigation, but our goal at that point is to mitigate the danger. And that's the number one role as a firefighter and emergency responder. Once that is mitigated, then we can come in and do the investigation and understand why that had occurred. But in small communities like where we live, very often it is the same person that does both. And it has to be a change over for an individual from one to the other. Does that answer your question? Now, Chief, you have a better answer for that than...
No, you're pretty much right on. And again, it was a transitional. We go out of the emergency suppression activities, and then we basically put on a different hat and we go into a different mode of activity. We're now, as Dr. Gavin says, we're trying to do origin cause on the fire, where it started, what happened, and how can it be prevented.
Any other questions? Yep.
How good do arsonists get sometimes? I mean, since they know, I assume some of them, if they do this, know this. Like, are they tricky? I mean, is it hard to find somebody who's really good at it, I guess?
Yes. Yeah, it is. There are professional arsonists, just like there, are people who are hired for all sorts of other crimes, and they can be very tricky at hiding some of their different tools and techniques that they use. There are serial arsonists that a gentleman who used to teach in our program was a 50-year investigator up in Chicago, and could tell you all sorts of stories about individuals where they were able to pin, hundreds of fires on an individual. But sometimes it takes a certain pattern. Even around here, we will have serial arsonists, but certain patterns sometimes pop up. There's also some things that we know about how things burn. Even though they may look alike, we can do chemical analyses, but there are some very smart criminals who can use arson for profit or for revenge, or all the other reasons that we talked about there that can be very challenging to determine. So that's why sometimes it takes multiple of these fires before you can find that pattern, just like any other pattern of crime, to eventually pin it on the individual or the group of individuals.